Okay.
So the complementary function, then the particular solution, and then adding them together. And for the particular solution, this is really, basically you need to know this and this. These two things right here. That make some sense? Okay. So that is the first problem on the review sheet. Probably the longest one, to tell you the truth. Anybody want to ask me any questions about the process? I know last night you didn't get to hardly think about it, and tonight you get to think about it a little bit more. Hopefully it makes more sense. Dennis?
What is your final answer?
It's in this box in the middle.
Okay.
Yeah. It's in the box in the middle there. Okay. Everybody all right with that? Now I'm going to be, as I said, I'm going to be jumping around on this review sheet a little bit. So I'm going to show another problem to you now. Oh, this is section 7.6. This is the very last section that we just covered last night in class. 7.6. Okay. Everybody all right?
I have a question.
Yeah, go ahead.
Why isn't there a C3 in front of the last part?
Remember that this second part down here on the bottom, that is actually a particular solution. So the general solution, the complementary function, is a whole family of solutions. It's a vector space that's two-dimensional, and you've got to have constants in front of the basis vectors. But this is one particular solution.
Okay.
Yeah, that's the reason. Does that make some sense? Good? All right. I'm going to throw another problem at you out of the blue. Don't know where it's coming from. Actually, I do know where it's coming from. It's number 9 on the review sheet. I'm going to write it on the board for those of you who don't have it with you. Let's solve y prime minus 3 over 2x times y equals 6y to the 1/3 x squared ln of x. And see who's the first person in the room to know what this has anything to do with. Oh, you guys are fast. Yes. Okay, I look at a problem like that. I say, it's a differential equation. So it must be either from chapter 1 or from this recent stuff. How do I decide? Well, is this a system of equations or is it one equation? One, right? It's just one differential equation. What is the order of that differential equation?
One.
First order, right? These questions that I'm asking right now are the same questions you guys should be asking yourselves when you see problems like this. So this is a single first order differential equation. Where did we learn about those? The beginning, chapter 1, exactly. So now we can start to look at it more closely and say, okay, I know it's from chapter 1. What kinds of equations did we learn about in chapter 1? Oh boy, this is way back to August. So we learned about separable, linear, homogeneous or homogeneous, and Bernoulli. Right? Those are the 4 main types that I explained to you guys. Which one is this? I think you already told me. Bernoulli, right? This is Bernoulli. I'll just remind you the form of a Bernoulli equation. It has to have the form basically y prime plus p of x y equals q of x times y to some power. This is the form that a Bernoulli equation can be written in. Remember that it is not always presented to you in this form to begin with, right? In some instances, we have to do a little bit of algebra, rearrange the equation so it looks like that. For example, if there's a constant in front of the y prime, you have to divide it under, right? You need the y prime to be with a coefficient of 1 in front of that. Okay? Make sense so far? So now we are going to test your memory banks with a Bernoulli differential equation. Anybody remember what we do? So we need a change of variables, and u was the variable that we used. Does anybody remember the formula for the change of variables? Because this is the important thing to know. Not about u prime. Just u. What does u equal?
Isn't
Y. Not quite. 1 minus n. Yes. 1 minus n. Y to the 1 minus n. That's exactly right. So this is the change of variables that we need to use. So I'm trying to, at this point, I'm not interested in reviewing the entire derivation of the process, right? That we did that back the second week of the semester. Right now, I just want you to know what are the nuts and bolts of the important things you have to know. This is one of them, because if you don't know the change of variables, you're not going to be able to convert things correctly. The other thing that's important to know is what happens to this equation after you transform it with this change of variables. Okay? Does anybody happen to remember what changes about the equation when you do that?
It turns into first order.
Say again?
It turns into first order.
It's already first order.
It turns into
Homogeneous. Non-homogeneous.
U plus 1.
It starts with an L.
Linear.
Linear. Yes, it becomes linear. After I do this change of variables, it becomes linear. So linear equation, u prime, right? U prime. And then what happens to this term here to the left of the equal sign? Does anybody remember what happened?
we have an integrating factor?
We're going to get to that.
Okay.
We're not quite there yet.
1 minus n.
A 1 minus n factor shows up. That's right. 1 minus n times p of x times u. Right? And then on the right-hand side, we also get 1 minus n times q of x. And the y to the n actually just disappears. Just disappears. So you end up with a new differential equation. And this one, my friends, is now linear. Right? The thing that made the original problem not linear was y to the n, remember? You cannot have unknown function times unknown function and have it be linear. But as soon as that y to the n drops out, what you're left with is linear. Okay. Okay, so in this particular problem, let's start thinking about this problem. What is the value of n up here?
1/3.
1/3, right? 1/3, very good. Okay. So I already know that u is going to equal y to the 2/3. Right? 1 minus 1/3. Okay? And then my new differential equation is going to be u prime plus, now 1 minus n is 2/3 of p of x. Now p of x is given right here as the coefficient of the y, but please be careful, the minus sign is included in that. So I still have minus, there should have been minus actually, minus 3 over 2x. Be careful about the sign change. There is a sign, a minus sign there. Okay? And then that is times u equals 2/3 of the q of x. But q of x is what?
X squared ln.
Everything on the right-hand side except for the y to the 1/3 part, right? Because that's the part that we separated out. So it's really 2/3 of everything else, which would be 6x squared ln of x. It'll look like that. Okay, so what we have here is u prime minus 1 over x times u equals 4x squared ln of x. And this is my new equation. I need to try to solve this. Okay, so what kind of equation did this become?
Linear.
Linear. Okay, good. Next question is, does anybody remember how to solve a linear equation? Pardon me? Okay, we need to find an integrating factor, right? Integrating factor, capital I. This goes way back to the first few sections. So the integrating factor, if you remember, is e to the integral of
P of x.
p of x dx, right? This is a formula everybody should know. And of course, we can rewrite that as, what is the p of x right now?
Negative 1 over x.
Negative 1 over x. Very good. Negative 1 over x. Okay. So when I integrate that, I'm going to get e to the negative ln of x, right?
Mm-hmm.
Okay. By the way, the x has to be positive here. You can't take the ln of a negative number, so should just mention that. E to the negative ln of x, that's just going to be 1 over x. Does that make some sense? 1 over x, that's the integrating factor. Now, what happens is you take the integrating factor, multiply by the unknown function, which is u right now, and the product derivative of that. Right? The derivative of that product has to equal, well, we take the right-hand side, and we multiply it by the integrating factor. So we're going to get 4x ln of x. Does that make sense? 4x ln of x. And, okay, now what do we do next?
We integrate both sides.
Integrate both sides, very good. So when I integrate on the left side, of course, I just get the integral and the derivative cancel. And when you integrate on the right-hand side, of course, you have a factor of 4, and then you need to know how to integrate x ln of x. Did everybody do that integral last night, too?
Yeah.
You had to do it last night. If you did it correctly on that the variation of parameters problem, integral of x ln of x showed up. So I added that to your table. I don't know if you noticed that. But that integral for x ln of x wasn't originally on the table before, but then I decided I really like this problem, except integral of x ln of x is like kind of annoying. I mean, it's not that hard. You can do it by integration by parts. But again, I didn't want to throw the focus on doing the integration. So you'll have this in your table, because my new and improved table has it in there. And the answer is going to be 1/2 x squared ln of x minus 1/4 of x squared. And by the way, I made one little omission here. When you do the antiderivative in this exponent of the integrating factor, you do not need to put plus c. I said that before, but I just want to remind you again. You do not need to plus c there, but you do over here. Because now we're in the process of solving for the final general solution. You have to put the plus c. You know? Now we're almost done. All we have to do next is multiply. I'm going to do 2 steps at once here to save time. I have to multiply through by x, and then I have to raise to 3/2 power, actually, to solve for the y, right? If I want to solve for y, I have to take the 3/2 power. So y is equal to 4x times 1/2 x squared ln x minus 1/4 x squared plus c, all raised to 3/2 power. That look okay? All to the 3/2 power.
Maybe you just leave it there.
Yeah, we'll just leave it like that. Yeah, that would be totally fine. That would be totally fine. Okay? I'm going to use this board next. You're doing a great job, by the way.
I'm trying.
Thank you for your help.
Of
For Nicole or
course.
the viewers?
Hmm?
Huh?
For Nicole or the viewers?
I'm trying to make sure you can
I've
see the writing.
got to keep her entertained here.
The writing on the board because last time you
A couple
couldn't.
of you guys have a laptop here. I'm wondering, the problem is another professor locked this computer, so I cannot get on here. If I could dump this video onto a computer and then just transfer it to mine later, is that possible? You've got space for it?
Yeah.
Okay. That way I don't have to go down to my office like every 40 minutes to dump the video. Did you have a question?
Yeah, is the 2/3 power, is it over the whole thing or just what's in the front?
Oh, I'm sorry. We need to be very careful. It's over absolutely everything, right? Absolutely everything. And that's 3/2 power, by the way. Yeah, 3/2 power. I'm sorry. Yeah, Nicole's getting it.
I
The
got
whole thing
it.
to the 3/2 power, that includes everything. The 4x and everything has to be the 3/2 power. Okay. Everybody happy with that now? Ozzy? See, it's because of this. It's from right here. U is equal to y to the 2/3. So if I want to solve this for y, what I do is I raise both sides to the 3/2 power. So y is equal to u to the 3/2 power. Okay, so we all good with that? All right, I'm going to give you another problem. We're going to keep them coming. We're actually making good time. We're reviewing a lot of stuff. You notice I didn't just ask you to solve a linear one. I made it Bernoulli so we are reviewing both methods at once. All right. Okay, I'm going to throw something else at you. Let's see who the first person is who can figure out what this is all about. Well, this is not number 3. This is because I'm doing them out of order. This is number 10. Solve y double prime plus 9y equals 18 secant cubed of 3x.
Variation of parameters.
Go. Oh my gosh. So fast. Say that again.
It's variation of parameters.
Variation of parameters. Does everybody agree? How do you know so fast?
Because you can't annihilate the other side.
Okay, before I get even to what I can annihilate or not, what's a more fundamental question you look at when you look at that equation? Second order, right? So you're saying this is not chapter 1. Right? Chapter 1, we were only concerned with first order equations. This is second order. So it's higher order differential equations. It's non-homogeneous because there is something on the right-hand side, so I'm not just going to find an auxiliary equation and be done. I have to figure out how to deal with the non-homogeneous component of it, and we only learned 2 methods, which were what?
Annihilators.
Annihilators and variation of parameters, right? So on the midterm last night, I had one of each, as you noticed, I'm sure. So the question really comes down to, do you know how to annihilate the secant cubed of 3x? I sure don't, okay? Because it's really a reciprocal cosine, which means when you take derivatives, it just gets worse. It doesn't simplify very nicely. So I don't know how to annihilate it, besides it's not in your table. So don't have to worry about that. So the only possibility here is variation of parameters. Guys, even if you just sort of know that much, you should write that down on your paper, right? You'd be surprised what I give partial credit for. I particularly like it when I can see that people know what method to use. Even if the process you make a little mistake along the way, if you knew the right method, that's so much more important to me. So for variation of parameters, let's see. There's 3 steps here again, right? Step 1 being what?
Take the Wronskian. Or no.
We need
sorry,
to find our complementary function.
The complementary function, right? I have to find the complementary function first. And how do I go about doing that? Okay, what's my auxiliary equation, Mary?
It is r squared plus 9.
R squared plus 9?
It's equal to 0.
Is that an equation? E equals 0. There we go. Sorry, just making sure we're very precise. Okay, that looks good. Can anybody solve that for R for me?
-3 plus or minus 9. No, yeah.
It's 3.
When in doubt, of course, on a quadratic, you can always use a quadratic formula. What did you say, Nancy?
Plus or minus 3i.
Yeah, plus or minus 3i is what I'm looking for, guys. Okay, plus or minus 3i. You square that, you're going to get 9i squared, which is -9. Add that to 9, you get 0. Okay, so we get these 2 roots. So that means I'm going to get 2 solutions. In fact, we can go right away and write down the complementary function. This is y sub c of x. And what would the equation be that we would get?
C1.
C1 times...
Cosine.
I usually use cosine first, John. It doesn't matter, but I'm going to put cosine first, just because I tend to do that typically. And then what's the next one?
C2 sine of 3x.
Good. Plus C2 times the sine of 3x. And it's important right now to realize that you have y1 and y2. Okay. So there we go. We've got our complementary function. That's step 1. All right. What's next?
We have to find our Wronskian so that we have our y1 and y2.
Yeah, we need to find the Wronskian. Just to remind you why, when we do step 2, we're going to be looking for a particular solution. And the particular solution is going to have the form u1 y1 plus u2 y2. And the y1 and the y2 are already determined here. I'm just going to solve for, I'm going to take out c1 and c2 and put in u1 and u2. And you remember the formulas for the u1 and the u2. Did everybody remember them last night? I haven't graded that problem yet, so I don't know how it went. But u1 is negative the integral of y2 f over the Wronskian. And u2 is positive the integral of y1 f over the Wronskian. Okay, so I need the Wronskian, right, to really work this out. So let's do the Wronskian next. The Wronskian is the determinant of, it's going to be a 2x2 matrix. If you remember, what you have to do is put your original functions on the top row, and then the derivatives of those go below that. So negative 3 sine of 3x and 3 cosine of 3x is going to look like that. Okay, so far? What do I get when I take that determinant? 3. It's just 3. Do you see that? Because you're going to have cosine squared plus sine squared, and there's a factor of 3 that comes out of both terms. So the Wronskian is just 3. Okay? So far, so good? All right. Where am I going to go? I'm going to erase right here, if that's okay, so I can keep on the same board. Somebody's written down that complementary function. I may need to call on you to help me remember it in a minute.
It's in the Wronskian.
That's there. It's just in the Wronskian, exactly. Okay, good. So let's do u1. u1 is negative the integral of y2. y2 was sine of 3x. And capital F, what's capital F?
18 secant cubed.
Thing over here, right? Yeah, 18 secant cubed of 3x. And we're going to divide this whole thing by 3. And of course we have dx there. So 18 over 3 is just 6. So I'm going to pull out negative 6. And then let's think about what's left here. I've got sine on top, and I've got really 3 cosines on the bottom. I'm not very good with, cosecants and secants, so I tend to turn everything into sines and cosines. So if I turn everything into sines and cosines, I've got sine of 3x over cosine cubed of 3x. Now that's not in your table, but I would expect people to be able to do this one.
The U substitution.
Yeah, you can do a U substitution here. What's a good U substitution?
Cosine of 3x.
Okay, so if I do a U substitution, I let U equal cosine of 3x, then the du would be negative sine of 3x times 3 times dx. And see, I already have, oh, that's actually kind of handy. I've pretty much got negative 3 sine of 3x dx if I just change this negative 6 to a positive 2, right? Let me absorb the negative 3 inside the integral. Then this is just the integral of du over u cubed. Okay? And so this is the integral of u to the negative 3, which is just u to the negative 2 over 2. Do I need a plus c on this?
Negative.
Oh, u to the negative 2 over negative 2. Yeah, right. Do I need a plus c on that?
No.
Nope, I don't need plus c. So this is just actually negative of,
Secant squared.
yeah, u, let's see, u to the negative 2 is 1 over u squared, which would be cosine squared of 3x. Okay? Let's see for a second here. Yeah, that seems okay to me. Everybody good with that? Okay. So that's the U1. All right, that's U1. And then we got to do U2 as well. U2, see if I can fit it in this little space. U2 is the integral of y1, which was cosine of 3x, times 18 secant cubed of 3x, all over the Wronskian, which is 3, dx. I think this one's easier. Because this one, if you take the 18 over 3 and make 6, then cosine and secant actually cancel out, right? They cancel out. So you're really integrating secant squared of something. Does anybody happen to know a function whose derivative is secant squared? The tangent function, exactly. So this becomes the tangent of 3x, but we have to be a little careful because the derivative of tangent of 3x is secant squared of 3x times 3. So I actually am going to have to divide this one by 3 as well and get just